Now we've seen that you can get a compound forming between a metal and a nonmetal by transferring an electron. The metal will lose an electron, the nonmetal will gain the electron. You'll get a positive ion and a negative ion, and those will stick together because of their opposite charges. So you've got a compound there that's made of ions. Covalent compounds are not metals and nonmetals. They are all nonmetal. And you don't get electron transfer. Instead, you get electron sharing. So ionic compounds did what they did because the atoms wanted to have the nearest noble gas configuration. They would gain or lose electrons to get the nearest noble gas configuration. In a covalent compound, it's going to share electrons until it gets the nearest noble gas configuration. To see how this works, let's look at hydrogen. Now, how many valence electrons does hydrogen have? 1. If I write the electron configuration down, it's a 1s1, right? So there's 1 valence electrons. I am going to write the valence electron down in a new way. I'm going to write it as a dot. When you write valence electrons as dots, you're writing down a Lewis structure. This is the Lewis structure for a hydrogen atom. Now what does hydrogen want to be like? It wants to be like the nearest noble gas, which is helium. How many valence electrons does helium have? It's 1s2. So it's got 2 dots. So hydrogen with 1 dot wants to be like helium with 2 dots. Where is it going to get the other dot? It can rip it off of something else, or if another hydrogen comes along, they can share. So if they're sharing electrons, you get a structure that looks something like this if you push them together. Now this hydrogen thinks it's helium. It's got 2 dots just like a helium, and this hydrogen thinks it's helium too. So they're both satisfied. They're both got that especially stable configuration that the nearest noble gas has got. This is the Lewis structure for an H2 molecule. This pair that I have in here is called a bonding pair. How does it bond the 2 atoms together? We'll look a little bit more closely at what I've got here. I've got a hydrogen nucleus on this side, an electron here, that's that dot, an electron here, that's that dot, and another hydrogen nucleus there. How is this going to be stuck together? Well, the positive charges are going to be attracted to the little cloud of negative charge that's between them that the bonding pair creates. So that holds that pair, because it's between the 2 nuclei, holds the 2 nuclei together. And it screens them from each other so that they don't repel each other. And that's how it works. Now, in the Lewis theory, very often what we will do when we're drawing Lewis structures, we'll not draw the bonding pairs as pairs of dots. We'll draw them as a little stick. So this stick is just another way to write the 2 shared dots. It's still a bonding pair. That's how covalent compounds form. They form molecules, so they are made of molecules. Ionic compounds are made of ions packed together. Covalent compounds are made of molecules. All right, let's let's play around with this Lewis theory. It's so much easier to write down an electron configuration as a Lewis structure than it is using the subshells or an orbital diagram. There's a lot less detail. What we're doing is we're discarding some details that aren't so important to us. Well, we can puzzle piece these together to get the nearest noble gas configuration. What do all the other puzzle pieces look like? All right. Well, let's look across the second period on the periodic table. The second row is the second period. Here you have lithium. It has got a helium core, and it's got one s electron in it. It's got a 2s1 configuration. So I can write one valence electron on top of the column. Now that doesn't just go for lithium, it goes for hydrogen, and it goes for sodium and potassium and rubidium and cesium and francium. Everything in that column has got one valence electron. So everything in that column can be written down as a Lewis structure by putting a single dot next to the element symbol. So this is an easy way to use the periodic table to decide what the Lewis structures for atoms are. Here, if I look at beryllium, it's helium core 2s1, 2s2. So it's got two valence electrons. And it's not just beryllium, everything in that column has got two valence electrons. And you can see where this is going. As I build up the electron configurations, I'm adding an electron every time I go over a block to the valence shell. So, for example, nitrogen has 5 valence electrons. It would have 5 dots around it. Fluorine has 7 valence electrons. It would have 7 dots around it. Same thing for iodine. Iodine is in the same column. It also has 7, so you'd put an I with 7 dots around it to do the Lewis structure for iodine. Let's play with this a little bit. Let's draw some other covalent compounds. How about we do, we're going to keep it simple. How about we do hydrogen and fluorine coming together to make HF. So we want to write hydrogen fluoride, HF, or hydrofluoric acid is another name for that compound. Okay, well, let's write the Lewis structures for these. H is here, it has 1 dot. F is here, it has 7 dots. And I want to know, what does H want to have? H wants to have 2 dots like helium. Now helium is different, right? I've got an 8 written over the helium, but it is a weird element. It is unlike any of the other noble gases. All of them have 8, but helium is an exception. It's got 2 valence electrons, and you know that. You know it has a 1s2 configuration. So this one is an exception. Watch out for it. All the other noble gases have got 8. All right. So anyway, back to this. Fluorine wants to be like the nearest noble gas, which has 8. Hydrogen wants to be like the nearest noble gas, which has 2. So if hydrogen had 2 sitting next to it, it would be happy. It can get that pretty easily by sharing with fluorine. If you share those 2, you're going to get a structure that looks like this. That will also make the fluorine happy. And by happy, I mean it'll be like the nearest noble gas because it'll have its 8 around it. So fluorine thinks it's got 8, which we call an octet. Most elements, except for hydrogen, want to have an octet around them. Hydrogen just wants to have helium's configuration, so it is satisfied with just 2. So here's my structure for the hydrogen fluoride molecule. I could write it this way, which is better. I'm going to take that bonding pair and I'm going to write it as a stick to show that it is a bonding pair. But I have something a little new here. I have 3 pairs of electrons that are not bonding pairs. They are not shared. Unshared pairs are called lone pairs. So if I want to describe the Lewis structure that I just drew to someone, I will say there is a bonding pair between the hydrogen and the fluorine. And there are 3 lone pairs on the fluorine, I can say. Let's do another one. Let's do O2. Okay, here I have an oxygen. It's got how many? There's oxygen. It's got 6 valence electrons. Here's another oxygen. And it's got 6 valence electrons. How many do they want? Well, oxygen wants to have an octet, just like neon. So it wants to pick up 2 more electrons, right? And this oxygen is the same. It wants to pick up 2 more. How can this oxygen pick up 2 more? By sharing with the other oxygen. There it picked up 1 more. Here it picked up 2 more. Now, if I share those electrons that I marked, I'm going to end up with this. Now, how do I describe this? There are 2 lone pairs on each oxygen. There's a total of 4 lone pairs on the whole molecule. There are 2 bonding pairs here. Notice that I can have more than one stick here. This is sometimes called a double bond. A double bond is 2 bonding pairs. Let's try to do a covalent molecule for N2. Here we have a nitrogen and a nitrogen. I'm going to look and see how many valence electrons they've got. 5. One, 2, 3, 4, 5. 5 on this one. Now, how many do they want? They want to be like neon. They want 8. So each nitrogen wants 3 more. So this wants to get 3 more electrons via sharing. So it's going to share there. That's 1 more. Share there. That's 2 more. Share there. That's 3 more. And if I wrote it down like in terms of dots, it would look like we got 3 pairs between there. I could write it down like that, or it's better to write it like this. Now we're going to talk a little bit more about this. There's a triple bond. We're going to talk a little bit more about double bonds, single bonds, and triple bonds later. But a triple bond is a lot stronger than a double bond. It's harder to break. You would guess that it would be that way. This is holding these 2 nitrogens together a lot tighter than that double bond is there. So there's all kinds of useful information about molecular structure that we can get from this. It is going to get to be a little bit of a pain to start to keep puzzle piecing them together when we get more and more complicated molecules. And we will see later a couple of worksheets down the line, like 3 worksheets down the line, an easier way to get these Lewis structures. And I hope I've given you just enough here for you to get a feel for why you get covalent compounds forming. The important point here, the big idea, is that you can share electrons to get the nearest noble gas configuration instead of stealing them or donating them. Instead of gaining or losing, you can share instead. And that's the big difference between covalent compounds and ionic compounds. They share.